We'll try this again. So, I had asked you to do this number 5 and 6 here as a warm-up. So, what do we have here? Well, we've got z equals -4. Really, that is z equals -4 plus 0i, correct? Okay. Which that's in standard form. In ordered pair form, that would be the point -4, 0 on my real and imaginary plane. Okay. Which is, if I'm graphing that one, it's straight out to the left. Right? So that gives me an R value here of 4. Okay? If I put square -4 and square 0, add them together, I get positive 16. Take the square root of it, I get 4. Okay? My theta, okay, is going to be 180 degrees. Right? Because I'm straight out to the left. Okay? If I did the inverse tangent, I would have gotten my theta prime to be 0. And because I'm in that negative direction, I could either do 180 degrees plus 0 or 180 degrees minus 0 because I'm not really in either quadrant. Okay? So we get that. So then this means then that z here is 4 times the cosine of 180 degrees plus I times the sine of 180 degrees. Agree with that? Okay. Fantastic. Number 6 here, that one is already in standard form. In ordered pair form, this would be -1, 6. Okay. So my R value then would be -1 squared plus 6 squared, and then I take the square root of that. Well, that's going to be -1 squared is 1, 6 squared is 36. Add them together, that gives me the square root of 37 for my R value. Okay. Theta prime, because I'm not in quadrant number 1, is going to be the inverse tangent of B divided by A, dropping the negative sign. So that gives me the inverse tangent of 6, which is, what is the inverse tangent of 6? 80.54. Okay. So that's 80.54 degrees. Which quadrant am I in? I'm in the second quadrant. So because I am in quadrant number 2, my actual theta is going to be 180 degrees minus 80.54 degrees. So what's that? 99.46? Yes? Okay. So the trig form of this one would be z is equal to the square root of 37 times the quantity, the cosine of 99.46 degrees plus I times the sine of 99.46 degrees. Look at that, I even fit it right in there. Yay. Okay? Good to go with that. Okay? We'll do some more of that here in a minute. Okay? But let's move on now to when we can change a complex number, a complex trig form number, into standard form of a number, or of a complex number. Okay? So, as you can see on the next page in your note packet, there are two options that we can go with here. Okay? So, let's talk about here option number 1. Okay? And option number 1 is the calculator option. Okay? Option number 1 works no matter what. Okay? You got to kind of make sure that your calculator is in the right kind of mode. If the angle that's given to you is in radians, make sure your calculator is in radians. If the angle that's given to you is in degrees, make sure your calculator is in degrees. Okay? And so really all you're doing here is you are distributing this R value into the parentheses. So this would become here 8 cosine of 135 degrees plus 8 times the sine of 135 degrees times I. And so you would have to calculate those individually on your calculator. So you would go 8 times the cosine. Oops, I thought I had that open. So you would go 8 times the cosine of 135 degrees. Oops, not tab. Hit the wrong one. I wanted to hit this one. Control. There we go. And so we get negative, let's call it negative 5.657. Plus 5.657I. Because if I did 8 times the sine of 135 degrees, 8 times the sine of 135 degrees gets me that. Okay? All right? So that's option 1. That's it.
Is it always going to be like that with all the same?
No. This just worked out because 135 degrees is 45 degrees up, so yeah. Okay.
So you want like decimal form, not the exact.
This would be the decimal form, yes. Calculator would be the decimal form. What do you think option 2 is? The exact form. Yeah, exactly. So my option number 2 is the unit circle. 135 is on the unit circle, or 135 degrees is on the unit circle. So I can use the unit circle and be exact. Okay? Alright? It's kind of like back when we were in polars and we said, if it's on the unit circle, use that option. Use the unit circle to get your exact answers. Okay? It's the same category here. Option 2 only works if our angle is on the unit circle. Option 1 works all the time, but if our angle is on the unit circle, we want it on the unit circle. So if I still distribute this before, so then this becomes 8 times the cosine of 135 degrees plus 8 times the sine of 135 degrees times I. Well, the cosine of 135 degrees is negative square root of 2 over 2. The sine of 135 degrees is positive square root of 2 over 2. When I do this multiplication, I get negative 4 times the square root of 2 plus 4i times the square root of 2. And when we have radicals involved, remember we put the I out in front of the radical, but if there's numbers involved too, then we make an I sandwich. Okay? And if I were to do, on a calculator, -4 times the square root of 2, we get the exact same thing. Okay. It's just a matter of exact and rounded. Okay? What I would like you to do now is I would like you to do number 2. And then we can talk about number 2 in a minute. Alright, so if I distribute this in, that becomes -6 times the cosine at 3 pi over 2 plus -6 times the sine at 3 pi over 2 times I. Right? Cosine at 3 pi over 2 is 0. Sine at 3 pi over 2 is -1. -6 times 0 is 0. -6 times -1 times I is plus 6I. Okay. Which we could then also just write as 6I. Okay. Now, if you think about this, okay, on the complex coordinates, or, on the real and imaginary axes, the complex coordinates, okay, A's and B's, where is 6I? Straight up 6, right? Okay. So, in the complex, real and imaginary, that we're talking right up here. Yes? Okay. But if you think about it, where's my angle? Where's 3 pi over 2? Straight down, right? So my angle is down here of 3 pi over 2. But how did I end up going straight up? What do you mean? Nope. There's one key part to this.
Is it
The
the -6?
-6 part is just like polar. Okay? If I'm going in a negative direction on this, or a negative radius, I should say, a negative R value, that means I got to go the opposite direction. So I would go negative 3 pi, or -6 from 3 pi over 2 is up there. Okay? Just like with polars. Okay? All right, now let's get into some multiplying of complex numbers. Woo! Yeah. Okay? So, if I say that z sub 1 is 3 plus 4i, and I say that z sub 2 is 5 minus 12i, and then I say, what is z sub 1 times z sub 2? Okay? Well, what I'm asking there is, I am asking for 3 plus 4i times 5 minus 12i. Can we do that? Okay. Help me out. Walk me through this. What do I do first? I'll multiply two complex numbers in standard form. Double distribute. Okay. So 3 times 5 is 15. 3 times negative 12i is negative 36i. 4 times 5, or excuse me, 4i times 5 is 20i. And 4i times negative 12 is negative 48i squared. Yes? Can I simplify anything? Okay, what like terms can I combine? Okay, can I combine anything else?
You can make the I squared negative 1.
I squared is negative 1, so this right here, this one becomes really plus 48. If I make I squared be negative 1. And then now when I combine them, now I get z sub 1 times z sub 2 is 63 minus 16i. Yes? Okay. So let's remember that. Okay. So let me come back down here and let me rewrite these. So z sub 1 here was 3 plus 4i. Z sub 2 was 5 minus 12i. And z sub 1 times z sub 2 was 63 minus 16i. Yes? Okay? So, what I would like you guys to do now is I would like, let's go with you three over here. I want you to convert the blue one, z sub 1, into trig form. Okay? And then compare. Middle two rows, you're going green. Okay? Convert z sub 2 into trig form. And you guys over here, convert our product, the 63 minus 16i, convert that into trig form for me. And then we'll compare answers here in a minute. All right, so what did we get? Blue people, what did we get for our trig form? What do we got? What do you got, Max?
5 parentheses cosine 53 plus 130 plus I sine 53 plus 130.
Okay, so green and red people, write that down. Okay, because you'd have you'd have 3 plus 4 squared, or 3 squared plus 4 squared is 9 plus 16. 25 squared 25 is 5. Inverse cosine, or excuse me, inverse tangent of 4 over 3 is 53.1 degrees. We're in quadrant 1. Works for me. Okay. Z sub 2, folks. What did we get there? Oops. Somebody in the Z sub 2 range. Ben's got it? What do you got, Ben?
13 times the cosine of 292.62 degrees plus I sine 292.62 degrees.
Okay. Again, 5 squared plus negative 12 squared is 25 plus 144, which is 169. Square root of 169 is 13. That's how we get R. Inverse tangent of 12 divided by 5 gets me a reference angle of 67.38 degrees. Because I'm in quadrant number 4, I subtract that from 360 degrees, which gets me 292.62 degrees. Love it. Okay? All right. Now, actually, what I'm going to do is I'm going to move these up a little bit so that I can move this one up a little bit. Oh yeah, I like it. Excited to be part of it. Red folk. What do we got?
65 times cosine of 345.75 degrees plus I sine 345.75 degrees.
The sine of 345.75 degrees. Yeah, like it. Okay? So you definitely, everybody else wants to make sure that you write down the two that you didn't have. Okay? Now, my question to you is this. Does anybody see, not one, but two patterns?
The R's for Z1 and Z2 multiplied together equal the R for Z, or is that considered Z3? I don't know.
My product?
Yeah, your product.
Okay? So 5 times 13 gets me 65. Okay? That's one pattern. Emily, I saw yours before Megan's.
If you add the two thetas, you get the theta.
If I add the thetas, I get my theta. Okay? Alright? This pattern will hold for all trig-formed complex numbers. Okay? You take the r's and you multiply it. Take the thetas and add it. Okay? Which is a lot easier than having to convert them both into, and then, or multiplying them out and double distributing and all that. Okay? Alright? Multiply the r's, add the thetas. Cosine plus I sine. Okay? Alright? Now, I added this next slide, so you're going to have to do a little sidebar action on this next slide. But now, I want to tweak this to division. Okay? So, if I still have z sub 1, and I still have z sub 2, but now I want to divide them, it would look like that, right? Do I like that fraction? Why not? There's an I in the denominator, right? Okay? So I have to multiply both top and bottom by the, not by the reciprocal, conjugate of the bottom, right? So I got to multiply by the conjugate of the denominator. So that's 5 plus 12i over 5 plus 12i. Okay? So my numerator now becomes 15 plus 36i plus 20i plus 48i squared. Do we agree with that? (15, 36i, 20i, 48i squared). Then I got to do the denominator. 25 plus 60i minus 60i plus, nope, excuse me, that should be a minus 144i squared. Okay. Top. What does the top become?
-33 plus 56R.
Bottom. What does the bottom become? Should be 169, right? Okay. But is that standard form of that complex number? No. So z sub 1 divided by z sub 2 is really negative 33 over 169 plus 56 over 169 times I. And that, oops, that shouldn't be. I love the Promethean board when it is acting goofy. Okay? Is the standard form, right? Now, what I want everyone to do is I want everyone to convert that into trig form. Okay? So convert z sub 1 divided by z sub 2 into trig form. Okay? We already converted z sub 1 and z sub 2. We did those from in the last problem. So I just rewrote those. Okay? So now walk me through the steps to converting z sub 1 divided by z sub 2 into trig form. What do I first have to do? Find the r. So r here is going to be negative 33 over 169 quantity squared plus 56 over 169 quantity squared, and then I take the square root of that, right? Okay. Which is going to be so if I go the square root of negative 33 over 169 and I square it plus 56 over 169 and I square it, that gives me oops, I forgot to square it. I got tap the brakes. Nope. Ah, come on, Linsmeyer. Riveting. There we go. There we go. 5/13. Yes? Okay. So this is 5 over 13. Okay. Now I have to find my theta prime is going to be the inverse tangent of 56 over 169 divided by 33 over 169, right? Trig inverse tangent of a fraction, 56, 1, oops, that didn't go 56. 56,169. And then I have another fraction down here of 33 over 169. Now, when I do mine, that's in radians. So I multiply that by 180 and divide it by pi, and that gets me 59.49 degrees. Which quadrant is this quotient in? It's in quadrant 2. So that means my theta is going to be 180 minus 59.49, which is what? 120.51 degrees. Yes? Okay. So that means that my trig form is R times the quantity of the cosine of 120.51 degrees plus I times the sine of 120. Oops. .51 degrees. Patterns, do they exist?
The R is just the R in the first one divided by the R in the second.
Yes? Second pattern, does it exist? Does that second pattern exist? Go back to the multiplication one, right? When we were multiplying two complex numbers, we took R times R and we added thetas, right? Dividing, we divided. So would it logically flow that if we subtracted theta? What if I subtracted 53.13 minus 292.62 in degrees? What do I get? Somebody with a calculator. Negative 239. Point what? 49? Okay. What's another way to label negative 239.49 degrees? Say loud. These are the same. Okay. At the top of your next page in the packet is a big box that has those two formulas in it. Okay? So when you're multiplying two trig-formed complex numbers, we take the r's and we multiply them. We take the thetas and we add them. If we're dividing two trig-formed complex numbers, we take the r's and we divide them, and we take the thetas and we subtract them. Okay? Right? And it matters which one goes first. Okay? Because order matters in division for sure. In multiplication, it doesn't. Yes, sir?
Is it always going to be like the opposite of...
If your second angle is bigger, yeah. You know what I mean?
So what would it be like
If they were reversed, it would just be regular.
like if 292 would have been the first number, it would have been...
If that would have been on top, yeah, if we would have went z sub 2 divided by z sub 1, then we would have gotten what would that be? 239.49 degrees.
Yep.